and our expert once again. Welcome to all in this teachers training program on recent advances and application of machine learning and IoT in mechanical engineering, offering by a joint venture of AICTE and RGPP Bhopal and organized by Sagar Institute of Science and Technology, Gandhinagar, Bhopal. So 3 days we have completed. This is our 4th day, and our first session will be delivered by Ms. Janani. So before starting the session, I would like to read her profile. Ms. Janani S, she is Controls Engineer in Control Engineering and Automation, Advanced Mechanical Service Private Limited. She completed bachelor's degree in engineering in electrical and electronics engineering from PSG College of Technology, Coimbatore. She has a total of 6 years of industrial experience in controls engineering, PLC, HMI, SCADA, electronic-based designing, and IoT. She mainly worked on process domain. Previously, she associated with JSW Steel Limited, Salem, in instrumentation and automation of blast furnace department. She involved in development of electronics boards for manufacturing industries, and presently working as a designer and developer for IoT products and services in control engineering and automation department of AMS India. So with this introduction, I would like to request ma'am kindly proceed for the session.
Thanks a lot, Nitin sir. I will be presenting now. You're able to see my screen, sir?
Yes, ma'am. Yes, it is visible, ma'am.
Okay. So hi everyone. It's very good to have an interaction with all the faculty members. So today we are going to see about the implementation of IoT in 3D printing machine and checking fixture. So I will give you a short introduction of what we basically do and how IoT has enabled us in coming up with Industry 4.0. So before we could start the session, I just wanted anyone to just come up with the idea what is the difference between IoT and IIoT. So can anyone just tell me what is the difference between IoT versus IIoT, because we already had few sessions before. So if that is clear, our session will be really interesting to know. So if anyone could just unmute yourself and let me know what is the difference between IoT and IIoT. Okay, so let me just tell it. So IoT is Internet of Things and IIoT is Industrial Internet of Things. So basically, IoT deals with the internet facility that is implemented in household sectors. Your refrigerator is on when you are in a remote location, you are able to switch off your AC. There are many commercial household appliances that have come in market. So all that are Internet of Things. Suppose you are implementing this IoT concept for an industrial sector, then it becomes an industrial Internet of Things. We use all these things in process industries, aerospace, mechanical engineering, process industries, by which I mentioned steel industry. So when you use this data capturing facility for a remote maintenance or remote analysis, then you tell it to be industrial Internet of Things. So as I said, in industrial Internet of Things or normal Internet of Things, we have 3 layers. So this is edge application. For example, you can consider a motor or a conveyor which is implemented with motor. So all these facilities will have a sensor attached to it, and the data of the sensor will be going to the gateway. Gateway is where it can be a controller plus a data moving protocol, or it is just a data exchange protocol embedded system. So with all these sensors, we will be making the program in the controllers, and that data we are going to send it to a cloud. Cloud is nothing but a storage area. So after storing, what we are going to do with the analysis is a different part. So we are going to store it in the cloud. So what we use between these two is called IoT gateway. So you have another gateway also. Normally in our home or office, we have a router. In router, you give something called gateway address. So when it comes to internet, normal internet, so gateway is exchanging your internet's data to some other internet facility. Means from your campus you are communicating with the other campus, or from your home you are communicating with other home. So these are the layers of IoT architecture. When it comes to industrial Internet of Things, this layer is going to be sturdy because your sensors, actuators, everything are going to be industrial standards. So this is the physical layer, and then you transmit the data, save it in a database. Then you create some applications, like many have got mobile applications for the smart city kind of application. So there you create some apps. So that is application layer. And business layer is when you are going to implement a smart city and one process industry and one like steel and one food industry. So you have to manage all these applications. So you have some business layer which is newly developed because IIoT has already been for few years. So it has come till business layer. First there were 3 layers, then fourth layer. Now we have 5 layers. So let me give a short introduction of what we actually do here. So basically, we do consultation for engineering, both controls and mechanical. We deal with automation, robotics, and we do PIW fixture designs and checking fixture designs as well. So as I said, we plan it, we design it, we manage the complete projects. After that, verification, validation, and complete execution will be under our design team and consultation team. So these are some of the projects that we have developed, like IAMA plant automation for ABB and Mahindra automotive line. So basically, we do body in white and checking fixture designs for automobile, and sometimes for aerospace as well. So you can see all the fixtures, complicated fixtures that we have designed. So these are some other design that we have done for ABB, through ABB to Renault. So these are projects with designing, mechanical designing again. So these are the 3D layouts. We do have softwares for making 2D, 3D layouts. And this is how we realize the design for the actual product. So we generally do welding fixtures. So that is normally the BIW, body in white fixtures. Um, so after making all these fixtures, we should have a simulation like how the part moves from through the conveyor line, and how we are going to actually mount it in the physical area. So for all this, we do have simulation softwares. We do robotic simulation, weld gun simulation, and whatever is related to automobiles. So we are expertise on designing and simulation of robotic cells as well. So this is a simulation example of RoboCAD software, and this is for Delmia. And this is process simulation. You can see how a robot is used for moving the process. And we do have, other than mechanical designing, we do designing controls as well. So here we basically do PLC programming. We do utility designing, power distribution panel designing, and I belong to that particular team. So here we have safety system as well. When we see through the industry, in industry it is necessary to have safety precautions or standards that is implemented. So we do take care of that through the safety standard PLCs. We design bar distribution panels. We do HMI as well. Here you can see the PLC architecture that we have developed. We do it with Siemens, Mitsubishi, Delta PLC, ABB, and ABB robots, Fanuc robots as well. All that programmings we do. And this is a cell architecture. We normally call something called a robotic cell. So in robotic cell, we will have a small PLC that is going to communicate with the robot depending on the application. So we do PLC architecture for that as well. So this is the power distribution, like from which panel, how we are going to distribute the power throughout the system. So the whole plant automation designing is done from our end. This is the utility design I was telling, like how air you are going to use, hydraulics you are going to use, and power you are going to use. So utility means pneumatic, hydraulic, and power distribution. So these are some examples of PLC programs that we have done, and this is the HMI, human machine interface, where you are able to view what is happening in the plant remotely. And SCADA system is supervisory control and data acquisition. So through HMI, you are going to view it, and the data is going to be saved at the back end, so that you call it as SCADA. So we do give on-site support for all this controls and mechanical designing that we have, that is developed by us as well. So as I said, we are good at robot programming as well. Mainly we deal with ABB, Fanuc, KUKA, Yaskawa, Panasonic, and OTC. So we can build a line of automation which is manual presently. We do give support. Only execution is expected from the vendor end. So we do have some certificates that is needed for doing all this programming. Any company will not accept doing a program in any way. So you need some standards of how the PLC programming or robot programming should be there. So we are certified for all that, like BAS, ePlan, Fanuc, and KUKA. So Siemens is a very big brand PLC along with Allen Bradley. So Siemens TIA portal is what we use here for the HMI and PLC programming that I told earlier. So these are some automation technology, like Omron is a sensor, IFM is a sensor. Uh, so hope you have some ideas on sensors and actuators. So am I right? You already have good understanding of industrial sensors and actuators, right? Can I get some response? Nitin sir, am I audible to everyone clearly?
Madam, you are audible, madam. No. You may continue, please.
Okay. Okay, so these are the automation technologies like IFM, as I said, Omron, P&F, or sensors which are used for industrial standards. You can see some sensors that are used for lab purpose, like IR sensors, and all that cannot be used for industries because you have something called IP protection, industrial protection. So it will have dust and rain area. So all that will make these sensors come sturdy. So this Rockwell, Mitsubishi, Siemens, or the top PLCs, and Delta PLC is also there, which is available for some basic programming purpose. So these are the robots, as we said, which we work on. So we have wide expertise on all this automation things. Okay. Now we have seen mechanical designing that is implemented in industry, and we have seen control engineering as well. So these two technologies were already there in Industry 3.0. So Industry 1 is steam engine and Industry 2 is assembly lines, that is mass production. Industry 3.0 was implication of computer in these technologies. So during that time only we had this controls and mechanical design engineering. But presently, we are going for IoT. So, what is the addition that happens? So, you had HMI, you had SCADA. So, you get data. For example, let us take a motor. We get the feedback that the motor is off through the contactors that you use in controls. You get the motor is off. So you are going to press a button from HMI telling that switch on the motor. So you are going to switch on the motor, then it is going to pick up the contactor and the motor is going to run and it is going to show in the screen HMI that motor is on. That data is saved in SCADA as well. So now till this was already done, but all this are done in on premises. Suppose if you want to have the data remotely, then you have to implement information technology. So till now, manufacturing and controls engineering is called operational technology, and when you implement internet on that, you call it as IoT. So this data that you have stored in your premises, you are going to export it to a remote location, that is anytime, anywhere. The concept of Industry 4.0, just a second. Sorry for the disturbance. So we have this internet technology that is used. So anytime, anywhere is the concept. So I can see the data from anywhere in the world and anytime. Even at midnight, 12 o'clock, the company heads want to see what is the data, how is the plant running. For example, if you take steel industry, it is 24 bar 7. So we can't expect shift people to handle everything. Suppose there is an escalation, manager has to run from his home to the industry. So that is not preferable. So we have this IoT technology where you will be able to view the problems remotely without the need for human intervention. So you just need to have an app. If you are getting any problem with the industry, for example, there is a furnace and the furnace temperature has gone beyond a certain limit and the valve is not opening to cool it. So what we should do, you should get an alarm by yourself so that you can intimate your engineers or technicians of what they should do. So human intervention is not needed during the visible phase, that is you can get the data, and when this implementation goes on well, then we will be able to control the machine as well from a remote location. For example, I can open that control wall by myself. Suppose I get the message by 1 o'clock telling that the furnace is heated up, so I'll just tell switch on the motor. Then the motor can be switched on. In case if problem still persists, then we will be going for some human intervention. Okay. Now, what all we will use for this IoT industrial product? So, sensors, as I said, sensors are something which is going to tell us what is the readiness of the machine. So, we use P&F, IFM, Turk, Canon's Banner, Omron. These are famous sensors. So, PLC, you get the sensor data, but what you are going to do with that? So, you need a controller. So that controller will be top brands like Siemens. So you have got this. You want to send this data to a gateway. So communication between the PLC and the gateway can be done in many ways, like Modbus, Modbus, RTU, and Profinet. Alan Bradley has some protocols like ControlNet, DeviceNet. So all these protocols is used for moving it to the gateway. So you have sensors, that data you connect to PLC, you make some programs through a protocols, you are going to send that data to gateway, and gateway through internet protocol, it is going to send to a server. So I told about cloud. Cloud is nothing but a server. So cloud can be of two types, on-site and off-site. So this AWS, Azure, whatever your the words that we hear in IoT world now, are a cloud platform. So if you don't want to take the risk of maintaining a server in your premises, then we go for a cloud architecture. There they can give you storage space, or storage can be yours, only analytics we can do from their premises. So after getting this, as I said, we can do analysis from the data that is stored in the server. You generally call it as raw data. So that raw data you have to convert into a useful information. Otherwise, whatever data you are getting through IoT is of no use. So this is from this place that you get this machine learning, big data, artificial intelligence, everything. So first is data collection. So data collections, you have to go through all these phases. So we are not dealing with some kind of banking sector or home automation. So those data can be obtained in a different way. So generally information technology was dealing with customer service and um, banking sectors, as many would be aware of. So now information technology being implemented in industries, then you have to go through all these 5 architectures that I mentioned you to get to this server. So after getting, you will go through this analysis. For that we have different kinds of platform like Mindsphere given by Siemens, things both things works, and we do develop website as well, like Simple IoT, which I will be telling in the later part. So we have IoT enabled products, that is 3D printed machine, bottle shredding and checking fixtures. We will be seeing about that application today. So we have box joint technology also that is implemented recently. So these are some of the views of it. Okay. Now let us just jump into our actual uh, session. That is 3D printing machine. We do have a 3D printer by the name Hyrel. So it is mainly used for research purpose. So it is not like actual product that is being used. We are not into production. So this machine is basically produced for a research kind of thing, like what material can give you what shape, what is the temperature needed for that material, and how to get a proper printing. All these things, if you have to make a research on, our machine is really suitable. So we have 3 types of machines here for industry, laboratory, and biological research. Biological research means like we have to print a tissue, we have to print some cells, so all that are in research. So for that our machine will be helpful. I think I got a message, just a second. Okay, I didn't get any messages from your end. So let me tell about the features of this 3D printer machine. So we have a facility in Penia, Bangalore, and we have basically 4 models. One is standard Hyrel 3D printer, one is a tall 3D printer, then one is for laboratory, and one is for biological research. So it is made up of steel, and it is used for R&D purpose, as I told, and we can accommodate 5 heads at a time. Heads is the extruders from where the filament is going to get printed. So we can accommodate 5 in our machine, and if necessary, we can even accommodate 10 if it has to be customizable. So we have 60 different types of heads, and it can reach up to 450 degrees Celsius. And we have different kinds of filaments, pellets, powders, and even gels that can be printed in our machine. Um, so basically, we have plastic filaments as well. One second. Okay, so we have 3 axes basically, that is X, Y, Z, and we have 4th and 5th axis as well, which is used for tilting and rotating. So for all this, we have IoT integrated for inspection. So I will just brief you through that later part. First, let us understand what the 3D printer machine is capable of doing. So we have 80-watt laser attachment also for engraving purpose, and there is a microscope for inspection to see how well the part is printed. For finite element analysis, you just need a microscope to know if the minute particles that is printed is proper or not. Then we have UV light for photo initiation as well. So since we have implemented all this in the 3D printer, it is industry 4 compliant. So we do have mission vision as well to view the mission from a remote place. So these are our customers presently for this 3D printer machine like BHEL, BARC, IIT Delhi. So we have many customers who are doing research on our machine. So these are again some of the international customers like NASA, um, Virginia, VT Virginia. So we have so many customers from international side as well, because this machine is manufactured in US as well. So for India, we are supplying from Bangalore Pune factory facility. So this 3D printer, we are using a filament. So filament, we can get it from a vendor, and there is one more possibility. That is, we have a shredding machine. We tell that concept to be precious plastics. The plastics that we use, which are not recycled, can be put into the machine, and it becomes a powder. And that powder you are going to powder or pellet, and that powder or pellet you are going to put it into a filament extruder machine, and you are going to get a filament, and the same filament we are going to use it for a 3D printer. So it is just like a zero waste concept. So basically, this precious plastics is you get a plastic that can be recycled, just crush it. This is the website preciousplastic.co.in, where you can go and have a look into it. You just crush it, then you are going to make some useful objects like this. Crush it, make it a filament, and through that filament, make some objects using the 3D printer. So this is the shredder machine that we have developed, and this is the material that is collected. You are going to put it in the uh, filament extruder machine. Here you can see some opening. So here you are going to put that shredded plastics. So here the machine is going to give you a filament. So this is the complete cooling and a heat that we are going to provide for making a filament. So this filament that you are going to get is going to kept in the Hiral 16A, or whichever model printer that we have. So this is Hiral 16AS machine. So to know about the Hiral 3D printer softwares and more concepts, you can visit our website www.hiral3d.net. So there we have clearly mentioned what is the filament powders and what are the types of machine that we basically have. As I said, we have industrial research machine, we have a laboratory research machine which is smaller in size, and we have a biological research machine. So when it comes to the technical features, you can see this machine has two variants. So this is just a colors change. 16AS has yellow and blue color, and this 1680 is tall. That is, it has 120 cross 88 cross 153 centimeter. So it is floor mounting and used for industrial research. So here we have something called bed in 3D printer, where you are going to print the part. So that can be 120 to 200 degrees Celsius, and we have provision for sub-ambient option as well. So sub-ambient is you print it below the room temperature. So the chamber, because you can see it is closed. So we have a chamber, it is not open type like some small 3D printer machine. So chamber heat can be 55 degrees Celsius, and we can have two power requirements. If it is local, we can have 220 volts, 50 hertz, which is Indian standard, or we can have power requirement of 110 volts in some foreign countries. So the printing speed maximum can be given as 60 per second, and we have XYZ precision as mentioned below. We have three options: cold, warm, hot. So for all these three options, we have different kind of extruders. Extruders is, as I said, is from where the filament is going to melt and it is going to print. So this cold flow we use EMO SDS, and for warm we use old KRA, and for hot options we go for MK1 250. So MK1 250 is the temperature. So if it is MK2 250, this 2 means that it can be used for flexible filament as well. So MK1 450 is it can go up to 450 degrees Celsius, which I told is the maximum temperature that we are providing. So we do give laser options as well for making the etching. I told you about the three axis X, Y, Z, and ABC is also there. So A will be rotating, and B will be tilting, and C will be tilting as well as rotating. So we generally have motion control to the stepper motors. So we basically should have three stepper motors for XYZ position. So it is having a closed loop. A closed loop is you get the feedback of what is the position of the XYZ while it is printing. So this is the laboratory machine. You can see the size is very small, 200 mm, and it is knee design, like it is very small. So that is the knee design, and we use spindle tools in the space of extruders also. So I told three options: hot, cold, warm. So these are the hot flow extruders materials. Like through the hot flow extruders, you can print all this material. Through cold flow, you can print all this material, and through warm flow, you can build even glue, print even glue. So this is the same example, and you can see the extruders. I was telling you about the extruders. You can see it is going to come out. The filament is going to come out here. So these are the controls that we are going to implement to tell when the filament has to melt. That what is the heat it is going to take. So these are the three different extruders for hot flow, and these are the extruders, aluminum extruders. So when you have this pin UV, it prints and it cures. It prints, it cures, like that. It goes in a step. So that is an aluminum extruder, and this will be stainless steel. So here also you can see we are providing UV cure. So we have 60 different types of extruders. So that is the speciality of our machine. And here we have fan cooling. So this is an extra addition. If you want to this extruders an additional cooling fan, then you go for this. So plastic syringes also we do have for uh, working with the plastics, and diode laser. This is the diode laser we use for making the subtraction. Like basically, you know that we have three things. One is additive manufacturing, subtractive, and forming. So we give all the three. This can be used for subtractive manufacturing. So this is a box furnace, which after making the part, if you want to make it stronger, then you have to keep it in this furnace. So magnetic plate generally we use for peak material when it has to be kept in the surface of PEI, polyethernide. Then you use this magnetic bill plate. So as I said, these are some extra attachments. So here you can see a dial gauge. So dial gauge is basically like a sensor. So when I press a button from a remote place, it is going to fetch me the data, and I should be able to see it at a remote place. So this is why we call it as IoT inspection. Generally, for a 3D printer, you can see this 3D printer. So this hotbed layer has to be straight. It should not be slanting even in microns. If it is slanting even a bit, then you are not going to get a proper print. So here, if you want to know the data, why it is going slanting, or is there any problem with the machine, then this IoT inspection is really helpful. So these are again some of the attachments like CO2 laser, bending machine, and then a gripper attachment. So all this are extra provisions which can be provided. Okay, so we do have a maintenance website. So we speak about IoT. So I'm manufacturing a machine and giving it. So generally like ERP softwares, enterprise resource planning softwares, we have this simple IoT dashboard where we are going to enter the machines that we are sending, and you can be able to log in your complaint through this website if there is any problem. So it is like making the maintenance work ease. So for this machine, we have machine vision, OPC UA server connection. So that is how, because of this too, it's IoT enabled, and hence it is Industry 4.0 compliant. So how this machine vision and OPC UA server works, we will just go through that. So these are the some of the parts that we have printed, like ceramic, PLA, this is ABS. So these are some parts that is printed from our machine. So I was telling you about a biological research machine. So this has a build volume of 100, and it can go up to 75 degrees Celsius, and again it uses a stepper motor. So these are some cabinets that we use for bios, for the filaments to be um, made in a proper way. So here, when you are coming to bioprinting, you are going to give a pneumatic pressure or mechanical force. You are not going to heat it. You are going to give a pneumatic pressure or mechanical force to print it. So this is like a small collection thing. You call it as a scaffold. So here you are going to print the tissue or the cell. So for this, we are not going to use a common idea of heating. So again, as we said, it's pneumatic or mechanical force. So these are some of the papers published by us. You can visit this link, hiral3d.net, and we have many papers that is published on this biological research and remaining things as well. Just go through this if you are really interested. So as I said, here you can see the scaffolding, and you have provision in a software called Repetrel. There is a software called Repetrel which is available in hiral3d.net. So it is made from the Repetrel software. So it is freely available, and there you have the scaffolding provision also. You can see we are giving a scaffolding option here. So if you want to print something below your room temperature, then you have to use an RSD extruder. So now that we have seen about the head attachment, like you even have a wall, you have spindle motor, you have extruder. So what you are going to do with IoT in this 3D printer machine? As I said, one is IoT inspection, that is you have a dial gauge and you are going to know about the levels. So here, as I said, you're seeing all the parts that is useful after making 3D print. So where we are going to use for machine vision and data collection. So if you really want to know about all this in depth, then you can just have this training materials. We have collaborated with Siemens as well, and with a collaborator by Suprajiv, where you can get training for this 3D printing. So these are the certificates that we have got. So now let us see about it in a brief for some time. So we have this Hiral 3D printer. We have some parameters. Now we had extruder, we had extruder temperature, hotbed temperature, XYZ axis, and what is the prime, unprime parameters, and all that you have to transfer to a remote location. Suppose my print is going on for 3 days. You know, in 3D printer, the printing may go even up to 3 days, 4 days, depending on the size of your product, because we have a higher build volume printer as well. That is, that axis is 500 mm. So I just wanted to check what is happening. If you really want anybody to be involved in shifts, then you can have a camera attached to the 3D printer, and through internet you will be able to view the 3D printer printing through your mobile app, just by giving a link that is developed by us in the mobile app, mobile browser or laptop browser. You will be able to see how it is printing. So that is one. And another thing, as I said, is OPC UA server. So I have to pass this parameters to a remote system, one, I can see how it is printing, fine. But I just wanted to know what is the problem that is happening, or what is the parameter that I'm getting while it is printing. So I have to send this data to a remote PC through some transfer protocols. So what can be used? Generally for IoT, you have MQTT. So MQTT uses a TCP/IP protocol. So if you want to realize what is TCP/IP protocol, generally you should know this OSI model, open source interface model, which is used for information technology. So this is the physical layer, and generally you make the changes in the application layer. So Ethernet IP, if it has to be used for industry, as not a normal Ethernet LAN cable, if you use it for, if you have to use it for industry, then this physical layer has to be sturdy. That is, there should not be any error while passing the data. So in any system, we have to give IP address, subnet mask, gateway for internet to communicate with each other. So as I said, it is using TCP/IP. So what is the other one is UDP, user diagram protocol. So this TCP/IP has a port of 44818 and the UDP has 2222. So what UDP does is it just sends the data. It is not going to confirm whether you have received the data. But when it comes to TCP/IP protocol, it confirms you that yes, the other end of the device has received the data. So generally we go for TCP/IP protocol. But if your user data is not that important, then you can go for UDP. And in Ethernet IP, you can select both the option of TCP or UDP. And this port number is very important. As I said, for machine vision, that is, you are viewing the part that is being printed, we are going to give a IP address, but which is the place that application runs. So you should give a port. A system will have many ports. For example, HTTP is 8080, which is standard. If you give IP address of your personal laptop and give 8080, it means it is using HTTP. Like that, for our own dial-out application, we have to give a particular port. So if, for example, I give 4050 as my port, then if you give the IP address of the tablet in which the 3D printer is connected and the port number, then I will be able to see the uh, data in a remote system. So there are two main protocols, MQTT and HTTP. MQTT works on TCP/IP, as I said. You have broker and client protocol. So here you can see a broker. So this broker gets the data from a device. So here I have shown you a Raspberry Pi just for demo, but consider it as a 3D printer. Then I'm going to just send the data from the microcontroller that I have implemented. We have microcontroller that is embedded in the 3D printer. So that microcontroller is going to send the data to this MQTT broker, and I'm going to subscribe it. It is just like publish subscribe that we normally do in our life. So this is going to send the data how through a topic. For example, let us say I want to send x-axis position. Then I tell sensor x-axis or x-axis Hyrule 3D. I can send any topic. I'm going to publish to a broker and it will be staying here, and any number of clients can subscribe to it. I want the data from x-axis Hyrule 3D. So it will check if the client is needing that topic and it will send the same. This is how a MQTT works. And you have three level of service, 0, 1 and 2. It sends the data without confirmation. One is it will send at least once. Means it can even send duplicate datas, and exactly once is it will not send any duplicate datas, it will send exactly once. So this quality of service depends on the criticality of the application. For 3D printer, obviously we would need a QoS 2. And HTTP protocol is request response. Like the client is going to ask, in my system, I'm going to browse AMS India. So if I browse AMS India, the client is asking for a website belonging to AMS India. So it will just go to the web server asking a request. The server will search in its local database from where to fetch it, and it will fetch. So that is called response. So it is based on request response. So in these two protocols for IoT, generally we use MQTT because it sends many data. That is, HTTP can be used if you want to send bunch of data at a time, but MQTT can be used if you want to send the data continuously per second, or like for 5 seconds, 5 seconds once. Because in 3D printer we want the data to be collected. We don't want a bunch of data after 5 minutes or so. So we generally go for MQTT protocol. But we are using here OPC way. Why we are not going for MQTT is it is not yet developed to that level. So we are going for OPC way protocol, which is Open Platform Communication. So there was OPC already developed in the name of DA, HA, and A and D. That is data access, alarm and events, history. And it was using COM DCOM protocol that is based on Windows system. You can see here the communication was happening in Windows system. So the OS is fixed, and the communication is also fixed. But when unified architecture, it was introduced in 2008. So when unified architecture came, you can use this protocol in any embedded system. It need not be a particular operating system. You can even use it in Windows or Linux, or you can use it for any brand. Like I can use it for Siemens, I can use for Allen Bradley. That is how we could use it for Hyrel 3D as well, which is developed by us. So the architecture tells you that this native communication module is the one which is communicating with the microcontroller, which is getting the sensor data. And this OPC communication module is going to interact with the client. What is client? Suppose this is my Hyrel 3D printer tablet that is connected to the machine. So no, this will be the Hyrel 3D printer that is connected to the machine, because here you have the controller and devices. So which is going to send the data, you are going to tell it as OPC server. So it is going to send the data to a client. So the client is going to request data from this server, and it is going to receive it. So this communication module, what it does is it get the request from the client. Client is the remote system, and OPC server is the tablet which is connected to the 3D printer. So it is going to send a data telling that I just need some data from the 3D printer on this particular time. Like within for 1 second, I need the data. So that is going to be communicated by OPC communication module. This protocol has some standards like address space, nodes, and all that has to be followed by programming. We have implemented all this in the Trapetrel software, and that is how we are getting the data in the remote system. So between these two, we have a translation mapping module which gets the data and sends it to native communication module in its understandable language. As I said, we have three parts: data accesses, just accessing the data; alarm and events is, suppose my 3D printer reaches a temperature of 100 degrees Celsius, chamber temperature, it is not desirable, then I have to trigger an alarm. So history is, I want the 1 month data of the extruded temperature. So that can be got from this. So let me show you how we have implemented it. So in the server side, you need a tablet that is connected to the Hyrel 3D printer, and you have Repetrol software there, and you should obviously have an internet connection if you want to work with IoT. Then you have a client side, a tablet, internet connection, and an open source client. You can get a client for money also, but there is something called UExpert, which is open source. We have OPC Python, which is also open source, so we can get all that. So I'm clicking on Repetrol software from us. There is a tab called interface, and then we should click on OPC server. Only if we give live coordinates, I'm going to get the XYZ position. So when I click on this, I'm going to tell transmit and receive the data also. So I'm going to give the IP address of this particular tablet, and I'm going to set a port number. I was telling you I have to give a port number for this application. Otherwise, it'll not know which application it has to access from a remote place. So I give a port number, I give a username password for security. There is something called certificates also, which can be implemented if needed. So after I give start, I click on live coordinates to get this 3 axis, and if I give start, I'm going to get all the data that is there in the 3D printer. You can see X position, Y position, and what is the travel rate of that particular axis. All that we can see. You can see that the server is started. So this is the client side system, like a normal PC. You download this UA Expert, just click on plus icon and give the IP address from the server. You can see the IP address that we have given, it's 2.34. So you have to give 2.34. Then give the same username and give OK. It will ask for the password and then give the credentials. So when you're connecting, you can see I am getting all these messages in a remote system. So this is done within the premises. Suppose I want to access this data sitting at my home, then I should do a port forwarding concept, like that 4840 I have to port forward from the internet that is connected to the premises. So if there will be IT people in a particular company, they can just give access to that particular port, so that only that particular port is accessed and you are able to see it from anywhere. So you can see actual temperature, desired temperature, everything I'm getting in a remote system. So how well it is useful, I'm able to see my parameter. Even if I print for 2-3 days, I need not stay in my office. I can just see all this data sitting at my home. And through Mission Vision, I'm able to see the printing part from a link. So this is how IoT has eased the 3D printer part. So here, if you want to change the publishing rate, like 1 second or 5 second, we can do that. Um, so here, when I right click in this value and give some value, it is going to fetch me a message here. For example, I have changed the exposition to 10. So it is telling that the exposition is changed to 10. So if I am the operator working on 3D printer, then I can know, okay, if they have sent a 10, so I have to change it to 10. We are not directly controlling the machine, but OPC UA protocol helps in controlling the machine directly. For example, I send my exposition as 10, it should automatically move exposition by 10 mm. But since it is not preferable, it has some security issues. For now, we have not given that provision. But if the application necessitates, like it is needed for a particular application, then it can be given. So this is an event log. Suppose if I'm getting any error in my 3D printer, I can come to know from the node called event log. So this is how I'm able to see my error, my parameters, my machine, what it is printing from a remote location. Suppose I'm the operator and they want to see if I have any struggle or my operation is proper from an expert person, then all this IoT stuffs will be helpful. So I was telling you about checking fixture. We do checking fixture. Checking fixture is checking the dimension of body parts or some mechanical parts. Here we are checking the parts of the automobile. So we have a stamping gauge checking fixture, and open plugs is the back open area, or individual gauge for any particular mechanical part, and ring gauge is again for the door, and SPC is statistical process control tool. So for all this, we are making checking fixture here. So now I have a checking fixture. You can see here I have, this is the checking fixture developed by us. So you have a part. This is a door part that we have fixed. It's a Toyota part. So I have 3 dial gauges. This is a base plate which is strong, and I have given clamps and pins so that it is fixed properly. So I have three, 1, 2, and 3 sensors that is getting fixed when I just push this. It is a clamp. I just push this, it stays in a particular location, and all the readings that I have given goes to this control panel. And if it is within the tolerance range, that is how we have programmed, you will get a go or no go indication. So here you can see I'm measuring it through RS-232 protocol. I'm just sending it to a device which has a controller inbuilt, or the controller can be separate, and later I can link the controller and the gateway. So if this communication happens and my program runs, then if it is within the tolerance, I'm going to tell go indication and no go indication, and I can give you a tolerance. Means it is beyond my expectation, but it can means it may not be rejected, it can be accepted. So in such case, you will be telling it as positive tolerance. If it is on negative side, it may not be rejected, but still I want to improve it, then you can tell it as negative tolerance. So with all this data through LAN port or Wi-Fi, I'm going to send the data to a server. So from this server, I'm going to fetch the data, do some analytics, and show it in the user end. So this is the user end. User end can be a laptop or a mobile. So here you can see this is one of the application that we developed for checking fixture. So you have to give credentials because everybody should not be accessing it. So we do give credentials from the maintenance website, and when you enter your user specified limit, upper and lower limit, you are going to get this charts. So anybody who are already knowing this total quality management, statistical process control related analysis, you should be aware of this X chart and R chart. So X chart is the values average that is being plotted. So this is controlled limit from the user specified limit. For example, my user specified limit is 0.05 mm, and from that mm it is going to calculate upper control limit. There are already available charts for calculating it. So I have given an upper control limit. In this portion, you can see my process is out of control. So that is how the checking fixtures that we have developed here is going to show to the operator whether it is go or no go, and it is going to tell to a remote user. This may be a original equipment manufacturer. They can just see this through the login ID that it has gone beyond a limit, and there is some problem with the machine that is manufacturing this particular part at that particular point, and I will be able to correct it instantaneously. I need not wait for the next hourly meeting or weekly meeting and then tell there was some problem on a particular day. So instant data of the problem can be known. If suppose I'm getting in a long run uncontrolled process, then I can tell in that particular batch of products there is some problem with the machine. So this is how IIoT is going to help us in industrial base, and this checking fixture and Hyrel 3D we are using personally here, and that is how IIoT helps you in doing analysis and avoiding rejections. So this is the R chart, and we can get the CPCPK value also for that. So that's it for the day. So this is how we have implemented IIoT. So if there is any doubt, please let me know.
Okay, participants, if you have any doubt, any query, you can ask. Okay, so thank you very much, ma'am. The session was very much informative. We have learned so many things from this session. We discussed about we learned and we discussed about the differences between the IoT and IIoT. We also learned about the automation technologies, different integration services and products offered by AMS India. And we discussed in detail what is the 3D printing, how it works, its architectures and role of IoT, and the whole process of 3D printing. So that was very informative session, ma'am. Thank you very much. And thanks to give us a time and to be a part of this teachers training program. Thank you, ma'am.
Yeah, thanks a lot, sir. If there are any doubts, please free to contact me. And thanks a lot for giving this opportunity.
Okay, ma'am. I have just one query. The next session will be delivered by Mr. Vijay sir.
Yes, correct.
So, is he have the meeting ID?
Yeah, he has the meeting ID. He will join.
Okay. Okay. Thank you, ma'am.
Yeah.
Thank you, ma'am. Have a good day, ma'am.
Yeah. Thanks.